Hello everyone, myself Professor Tushar Gujrathi from SND College of Engineering, Yeola. Today we'll study a lab practice on implementation of PID control using Simulink. So Simulink is one important part from Matlab software. So in this Simulink part we can implement PID control very easily. So that we'll study now. So now what is step 1? Open Matlab from program menu. So we can start Matlab by double clicking on shortcut that appears on desktop also. When Matlab opens, below window should appear. So like this window appears. Okay. So now type Simulink at the command prompt and press enter. So here we have to type Simulink. Okay. Here you should type Simulink and press enter. Okay. So after pressing enter, Simulink opens and library should be visible. Something like this library should be visible. Okay. So in this library you see there are many options are there here. So input signal, continuous, discontinuities, discrete signal, lookup tables, math operations, that is plus minus, model verification, sinks and sources. Okay, sink means input, source means output. So like this there are some operators are shown over here. Okay, and also these operators are very important while solving any problem. Now step number 3, to create a new model, click on new model button. So there is new model button is also available. Doing so will open new model window. So like this window will appear, that is called as new model window. Now what is step number 4? Click on sources in the library window. So we'll click on sources over here. You can see here sources is shown. So sources, so like this sources will open all type of sources. So from this you can select step input. Okay, this is step input is taken. You can see the sources also. So what is there? First ramp input is shown, then random numbers are shown, then repeating sequence, repeating sequential interpolation. Okay, like this many inputs are there. Sine wave is also available, random input is available. So like this there are many inputs are available, but right now you only select step input, okay, as a source. Now step number 5, double clicking on the step input block will open block parameter window. Okay, this is block parameter window. So if you double click on any block, so it will open its setting option. Okay, so here in this block parameters we can set up the desired parameters, and once done we have to click OK. So here step time is we can include as 1, initial value is 0 and final value is 1, and sample time is 0. So like this we can give the parameters. So now step number 6, click on sinks in the library window. Now we have to click on here sinks. Okay, and like this outputs are open. So one is display is there, floating scope, output, scope is there only, stop simulation, terminator, XY graph is also there. So out of this we have selected now scope as output. Okay, so you can use drag and drop option also, means you can with the help of mouse you can drag the option and drop in the window. Okay, so like this you can drag and drop, and both the step and scope are connected with the help of arrow. There is arrow between them connecting both the blocks. Now step number 7, to save the file. The file will be .mdl format model. Okay, click on save as in file menu. Make sure the file is saved in the same folder in which Matlab's command prompt is running. Okay, also file name should not contain special characters. So you have to save the file in the same folder in which Matlab command prompt is running. Okay, file name should not contain special characters. This you remember. Now step number 8. Now to run the file, hit the play button. So there is play button is shown. Okay, so you have to hit the play button. Output will be visible after double clicking on the scope. You have to double click on the scope and you will get such a output. And simulation time can be altered as per requirement. So you can alter this simulation time as per requirement. So now here you got the graph. So the graph is step output. Okay. So as we have given step of only 1, so that's why we got step of output as a 1. Okay, this is the step that we got. Now step number 10. Click on continuous for the transfer function block. To modify block parameters, double click on it. So now if we need transfer function, then from this continuous option there is transfer function is available. Okay, this you have to drag and drop over here. So this is transfer function required. So there are many options are available in continuous, like derivative, integrator limited, PID controller is also available, PID controller. So all the options are available over here. Now after selecting transfer function, you double click on this transfer function option. Okay, so suppose the transfer function is something like this: s plus 1 upon s square plus 3s plus 2. So numerator is 1 1, coefficients are 1 1, and denominator coefficients are 1 3 2. Okay, so these coefficients we can enter. So now right now suppose you see here the transfer function is 1 upon s plus 1. Okay, 1 upon s plus 1. So here coefficients are numerator are only 1, so you have to write here 1, and denominator you have to write 1 1 by keeping space in between them in the square bracket. So 1 space 1, so like this denominator is taken, and like this you will get equation 1 upon s plus 1. Now step number 11. The PID block as well as summing block can be found in click on continuous and math operators respectively. Using this, complete the simulation of PID controller. At the end of new model window should look like below. Okay, so here from the same library continuous, you can select PID controller. This is the transfer function modified. Okay, and you can select summing point also from math operator. Okay, so like this you can get summing point also. So you can change sign also by double clicking on that block. You can give sign as plus minus or minus plus, what you want to give, by clicking on that summing point, double clicking on summing point. So like this you should get the all the blocks properly. Now step number 12. Scope block can be assigned multiple inputs by changing number of input in the scope parameter block. To open the block, double click on scope and then click on parameters. So now open the block, you can double click on the parameters and you can add their number of axis as a 2. Okay, you can double click on scope and you can add number of axis as a 2 or 3 4, what you want to add. Now step number 13. Assign 2 inputs to scope to check control signal as well as output. Assign 2 inputs to scope to check control signal as well as output. So now what we have done here, to this scope, this is one input and we have taken one more input as a PID controller input. So like this there are 2 inputs to the scope. Okay, and step number 14. Now run the simulation by hitting the play button. So there is play button available. We have to run the simulation, and depending upon the response of the system, alter the gains of PID to achieve the desired performance. Okay, so here we get 2 graphs now. As 2 inputs are there, we will get 2 graphs as output. So these are 2 graphs. Here yellow line is shown like something like this, we get something like this controlled output. Okay, so now by changing gains of PID, so here in this PID controller, if you change values of P, I and D, different values you take PID, you will get different outputs in the scope. Okay, you will get different graphs over here in the scope, and like this by changing different values of PID, you can control the output very easily. Okay, so like this the procedure for solving problems of mechatronics in Simulink option. So thank you so much all of you for watching this video. Hope you understood this procedure and you apply same procedure for solving same problem and you try to find out what is the output. Okay, so thank you so much.